To find function values from a graph, I find it very useful to think again in terms of inputs and outputs. On a graph, the inputs are on the x-axis and the outputs are on the y-axis. So if we want to find f of -1, that means we want to find the output when the input is -1. So if we find our input of -1, what is the y value, or the ordered pair that lines up with that? Well, if we trace up here, we see this point right here that is at a y value, an output value of 3. So f of -1 is 3, which means we have the point -1, 3 on our graph. Now f of 0 would be the input is 0, and we want to know the output. Well, if the input is 0, that means we are right here, and we trace up to our graph. There's our point. What is the output value? Well, the y value at that point is 5. So f of 0 is 5, which corresponds to a point of 0, 5. F of 1, for that, we want to go to an input value of 1. That's here. Trace up to that point right there. And it is at an output value, or a y value, of, well, 5, just like the other. F of 1 equals 5, which corresponds to a point of 1, 5 on our graph. Now, we can go in the opposite direction, use the graph of the function f to find the x value when f of x equals -4 and when f of x equals 0. That's telling us our output value, that's what f of x represents, the output value is -4. So what would be the input that determines that? Well, if I find an output value of -4, I need to find the input that would line up with that. So let me write that this way, actually. It'd be something -4. What x value would match up with -4? Well, if I trace over here, I've got this point right here, which has an input value, tracing back up here, of -1. So I have the point -1, -4, which means that f of x equals 4 when x equals -1. That's what I'm after. A similar process, f of x equals 0, it means the output value is 0, so I'm looking in this direction. Whenever my x values are, well, there's one here. Here, when my x values are -3, and when the x value is 1.